Hi guys, and welcome. In this video, we're going to learn about inverse trigonometric functions. So let us get straight into an inverse function. An inverse function only exists if the horizontal and vertical line cuts the graph once. So basically a function has an inverse if a function has an inverse if it is 1 to 1. What does 1 to 1 mean? 1 x value, 1 y value. So if we observe this function here, and if you try to cut them, you can see it cuts twice. We only want the function to cut once. So as a result, to get the inverse function, we need to block off a certain piece of the function in the sign to get the inverse sine function. So we are looking within this block. So if you look within this block, we have this turning point here. Let's look at the turning. Let's take some important points on the original function sine x, which we did in the previous video. So we got y equals sine x here. Taking some functions, remember this value is 1. So the coordinate over here is pi by 2. And the y value is 1. This value is basically 0, 0. This value is negative pi by 2 and negative 1. So we have 3 points. Now, remember the 3 points are, if you remember the 3 points on F, the 3 points on F are negative pi by 2 and negative 1, 0, 0. Remember, the more points you take, the better your graph will be, the curvature of your graph will be. And the last one is pi by 2 and 1. So the points for the inverse, the points on the inverse function will be negative 1 and negative pi by 2. Basically, you need to switch the x and the y. 0, 0, and the last point will be 1 and pi by 2. So the sine function has a starting point and an ending point. The starting point on the x is negative 1 and is ending at 1. So let's look at this. This is negative 1, and this point here is 1. You can see negative pi by 2 is somewhere around like 1.57. This is pi by 2, and this is negative pi by 2. So what's important over here is the shape of the graph. So there's one point, there's another point, and here's another point. You can take values in between, like the exact value of half. And you can take negative pi by 6, which will give me negative half. So you can add those 2 points there and get this. So if you go to negative half here, this point is around, if you go to negative half here, this point is about pi by 6, all right? And same here. Remember, this is just a point above 0.5. So remember, this is half, and this is negative half. And this will give me pi by 6, negative pi by 6, and this will give me pi by 6. I hope you understood that. Now, obviously, if you're going to join this, that's how you get this graph here turning out. You need to join about, you can't just join 3 points, because if you join 3 points, you'll end up with getting a straight line. That's why it's important to choose this point as well, like pi by and half. So transform that point, you need to add those points here, pi by 6 and half, and negative pi by 6 and negative half. So if you switch this around, you will get half and pi by 6 and negative half and pi by 6 negative. So if you join these 5 points, that's how you get the curvature of this graph. What's important on the curvature of the graph is the domain, because sine inverse function is a restricted function. It's a restricted domain. So x is an element from negative 1 to 1. And the range of this graph is basically from negative pi by 2 to pi by 2. Okay, so negative pi by 2 is the minimum value of the sine inverse function, and pi by 2 is the maximum value of the sine inverse function. Similarly, we do the same thing for cos graph. Only difference in the cos graph is we will cut this graph off. We need to look between this rectangular box here. So the important points on the cos graph is, and you can also see that this graph is curving, right? It's going like this. This thing is kind of reflected with x and y interchanged. Same here. We have this point which is pi by 2, and this point here as pi. So pi gives me 0, and 0 gives me 1. So points on F, the points on F are 0 and 1. Then we also get pi by 2 and 0. And we also get pi and negative. Right. Now, if you try to plot these points, you can see on the inverse function, on the inverse function, we have 1 and 0. There's 1 and 0 here. Then you got 0 and pi by 2. Remember, the value of pi by 2 is like almost 3.14 divided by 2, 1.57. That's the reason why we have that value there. So it's better to put pi by 2. And the last point over here is negative 1 and pi. Negative 1 and pi. The value of pi is 3.14. That's why we're ending off here somewhere. Right, so that is the pi value. And this is my cos inverse graph. So this is cos inverse function, cos inverse x. And this is y equals cos x. Continuing, that was sine x, and this is sine inverse x. Now going on to the next part. Similarly for the tan graph, but just be careful for the tan graph because the vertical asymptotes are at negative pi by 2 and pi by 2. These are the vertical asymptotes. So the vertical asymptotes now becomes horizontal asymptotes on the tan inverse function. So this becomes horizontal asymptotes. Because the vertical asymptotes were x equals, it was x equals pi by 2 and x equals negative pi by 2. The horizontal asymptotes will become now y equals pi by 2 and y equals negative pi by 2. That's approximately what the graph. You can clearly see that the tan inverse function goes very close to some limiting value. So this is the tan inverse. Now, how do we sketch the tan inverse function? You can see this graph in the center. So we're kind of like blocking this off with the asymptote. We are blocking this piece off because we need to make the function 1 to 1. Right, that's the reason why we need x values and y values. So you can see it was going through 0, 0. This one also goes through 0, 0. Now there are some important values on the tan graph, like tan of 45 degrees or tan of pi by 4 is 1. Pi by 4 is here, right? It is 1. And negative pi by 4 is negative 1. So now the negative pi by 4 will go on the y-axis. Yes. And the negative 1 will go on the x-axis, negative 1 and 1. And at negative 1, this value is negative pi by 4. And this value will give me pi by 4. So we should move this higher up because trying to make it symmetrical. All right. So this is the tan inverse function and this is the tan graph. Right. So this is the tan inverse function. Y equals tan inverse x. What's important in the tan inverse x is the domain. The domain of the tan inverse is from negative infinity to infinity. So it's all real numbers. And the range is very important, is y is an element from minus pi by 2 to pi by 2, round brackets. That's it. It has to be round brackets. Let's work out the domain and range for this as well. The cos inverse. The domain was x values is from negative 1 to 1. And the range is from 0 to pi. Right. So these are the three main type of inverse functions. Now, okay, that's asking the same thing. So the domain is x is an element. What's the domain here? Our cos x is an element from negative 1 to 1. Element from 0 to pi. This now. For arctan, x is an element of real numbers and y is an element from minus pi by 2 to pi by 2. Now, this is very important for problem solving. Note, we have a very important formulas for inverse function. F of f inverse x is always equal to x, or f inverse f of x is also equals to x. So let's prove it by means of examples, because we already know this. Find the inverse of f. So how do we find the inverse of f? Is we say f is a function, y equals 3x plus 2. To find the inverse, we need to switch the x and the y. So we swap the x and the y. So f inverse is x equals 3y plus 2. Solving for y, we're going to take the 2 over. So we say negative 3y is equal to negative 3y is equal to, take the x over, negative x plus 2. I took the 3y onto the right hand side, onto the left hand side, and brought the x over because I'm solving for y. Now, when you're solving for y now, you can say y is now equal to negative 1 divided by negative 3. So that's 1 over 3x. And 2 divided by negative 3. We have to divide everything by negative 3. So 2 divided by negative 3 is negative 2 over 3. And this is what your inverse function is. So f inverse x is this transformed function, 1 over 3x minus 2 over 3. I hope you guys understood that. Now let's prove these results. How come if I substitute the inverse function in the original function f of x, the answer is x. How come if I take f of x and substitute it into the inverse function, is the answer still x? So let's check if that actually works. So I've got f of x is equal to 3x plus 2. So this is f. We want to prove that it's equal to x, right? The result is x. So we're going to say the left-hand side is now equal to f. What is f inverse? F inverse is 1/3 x minus 2/3. Now I have to take this entire 1/3 x minus 2/3 and substitute into f of x. So replace it with x in the function. So that's basically equals to 3 times something plus 2. It's 3x plus 2, right? But x is no more x. It is 1/3 x minus 2 over 3. Now if I multiply all this out, 3 times 1/3 x is x. 3 times negative 2 over 3 is negative 2. And then plus 2. So yes, the result works. So the answer is x. So what we just proved, that f of f inverse x is always equal to x. Next one. What is f inverse f of x? Is it equal to x? So let's prove the left hand side. Left hand side is f inverse. What is f of x? 3x plus 2. Now we are substituting 3x plus 2 inside this function, in the inverse function. The inverse function is 1 over 3x minus 2 over 3. But what is x? X is 3x plus 2. What is x? 3x plus 2. Put it here. So we got 1 over 3 times 3 is x. 1 over 3 times 2 is 2 over 3. minus 2 over 3. So I'm getting an answer of x, which means f inverse f of x is equal to x. So it's proved. So you got to remember these results here. Next one. Do the same thing by means of second example. So we're going to find f inverse, the inverse function. So we will say the inverse function, no, f is a function y equals, what is the function f? Y equals negative 4x plus 8. F inverse is a function x equals negative 4y plus 8. Bring the 4y over, so we get 4y. Bring the x over, you get negative x plus 8. Now divide everything by 4. So y is equal to negative 1 over 4x, and 8 divided by 4 is plus 2, which is the inverse function. F inverse x is negative quarter x plus 2. Negative quarter x plus 2. Now, let's prove that. So remember, I've got f function is 4x plus 8, and my f inverse function is negative quarter x plus 2. Let's check if that works. Yeah. Now, let's prove these results and check if it actually works. So we got f of f inverse x. So left-hand side is equal to f. F inverse is negative quarter x plus 2. F is 4x plus 8. So 4 into something plus 8. 4 into what is x? Negative quarter x plus 2. We're going to multiply this out. 4 times negative quarter x is 4 times negative quarter x. So why do we have negative quarter x? We'll move the x over to the other side, brought that over negative quarter x plus 8. There should be negative 4 here. Yeah, that should be negative 4. So negative 4 times negative quarter x is x. Negative 4 times 2 is negative 8 plus 8. So we are getting the result, which is equal to x. What about this one? Left-hand side, f inverse. F of x is negative 4x plus 8. F inverse is negative quarter into x plus 2. And what is this x? There's no more x. It is negative 4x plus 8. So negative quarter times negative 4 is x. Negative quarter times 8 is minus 2 plus 2. So we are getting the answer. So we prove the result again. Excellent. Now let's solve some questions involving trigonometry. We want to know what is the value of sine inverse half. How are we going to get sine inverse half? We have to use the 30, 60, 90 triangle. So if you use the 30, 60, 90 triangle, we can actually solve it. It's a special angle, basically. So we can say this is half. We are finding basically the angle here, right? So half is opposite and hypotenuse, and this is root 3. So I think it will be 30 degrees here, right? 30 degrees or pi by 6. So what's the answer for this? It is pi by 6 or 30 degrees. Because when you solve this equation, you can say let y equal to sine inverse half. You can sine both sides. So you can say sine y is equal to sine of sine inverse half. And we just learned a rule that f of f inverse x is equal to x. So what is sine of sine inverse half? That cancels out basically this half. Sine y equals half, and y has to be equal to 30 degrees. So we already got the answer. This is just another method. Oh, so what's the answer for y? Y is equal to 30 degrees or pi by 6. And what is y? Sine inverse half. Let's find cos inverse root 3 over 2. We can use a special triangle. Root 3 over 2 is root 3 here and 2. So we can say this is just, again, pi by 6 or 30 degrees. Avoid using degrees, just use pi. Let's take out degrees and use pi by 6. Remember, it's the same special triangle. Next one, find the value of arc sine negative root 3 over 2. Right, so we want to find sine inverse negative root 3 over 2. Right, so we need to check where is sine negative, okay? Sine is negative in the third and fourth quadrant. So we're going to say let y equal, let sine y equals to negative root 3 over 2. So we're basically solving for y. So y will now be equal to sine inverse negative root 3 over 2. So this is a special triangle, but will it be in the third quadrant or will it be in the fourth quadrant? That's what we need to check. Remember the domain for sine inverse, the domain or the range for sine inverse is y is an element, because remember arc sine, right, so y is an element from negative pi by 2 to pi by 2. So negative pi by 2 to pi by 2 is the fourth quadrant. So sine is negative in the fourth quadrant. The diagram will go here. Then we can get the angle right. Right, so now we got negative root 3 over 2. Opposite is negative root 3 over 2. So this angle over here has to be 60 degrees. In other words, it's pi by 3, negative pi by 3. So what's the answer for y here? Y is equal to negative pi by 3. That's it. Negative pi by 3. And let me check if that will work. Negative pi by 3, which is between negative pi by 2 and pi by 2. Let's use the calculator to double check the answer. So shift sine negative root 3 over 2 is giving me negative pi by 3, which is correct. Right, excellent. Find the value of cos inverse cos of 60 degrees. See, they are also using degrees here. So it's fine. Remember, degrees is pi by 6, right? So we're going to cancel this out. Cos inverse cos cancels out. The answer is just 60 degrees, because f of f inverse x is always equal to the argument, which is x. So this is basically x. 60 degrees is better to write pi by 3. Pi by 3 radians. So what's the answer for this? Please use pi by 3. Moving on to the next question. Sine of sine inverse negative root 3 over 2. So those two can cancel out. So the answer is just negative root 3 over 2. Next one. This one is exciting because sine of sine inverse 5 over 13. So we're going to say let y equal to sine inverse 5 over 13. So what are you finding? You're finding cos y, because we already made this whole thing equal to y. So you want to find the value of cos y. Easy. So you're going to sine both sides. You get sine y is equal to 5 over 13. We draw a triangle, a right triangle, and draw it in the first quadrant. So we got 5 and 13. 5 is the opposite. 13 is the hypotenuse, so the adjacent is 12. Pythagorean triples. So, or you can use Pythagoras, theorem of Pythagoras. Square root 13 squared minus 5 squared. Square root of 169 minus 25. Square root of 144, which is 12. So sine y is 5 over 13. So what's the value of cos y? So this implies cos y is equal to, what is cos y? Adjacent of hypotenuse, which is 12 over 13. Remember, this is the angle y. I should have put some angles there. Yeah, so that's good enough. 12 over 13. So that's my answer. Therefore, what's the answer for this problem? The answer for this problem, cos of sine inverse 5 over 13 is 12 over 13. You can try typing it onto the calculator. Cos of shift sine 5 over 13. 5 over 13. Cos shift sign 5/13. Okay, and see what answer you get. You get 12/13, correct. Moving on to the next problem. Solve for theta if arc sine cos of is equal to pi by 3. So what we're finding, sine inverse cos x equals pi by 3. So because it's sine inverse, we can sine both sides. If you sine both sides, it becomes cos x equals sine of pi by 3. So what we have done is we put sine on both sides. We sine both sides. So what we have done is we said sine on this side and sine on this side. So it's the same thing. Putting sine here of sine inverse cos x is equal to sine both sides. That's what we mean. Right, so when you sine and sine inverse, that cancels out. You just got cos x. It cancels out because of the rule, right, that we proved in question 1 and 2. So cos x equals sine pi by 3. What is sine of pi by 3? That's sine of pi by 3 is sine of 60, which is √3/2. And cos x equals √3/2. That's a special triangle. So that will become pi by 6, cos of 30. So x is equal to, that's a special triangle, that's cos inverse √3/2, and x is now equal to pi by 6. Right, you can try that out on the calculator or use special triangle cos inverse √3/2, square root 3/2 should be square root 3 pi by 6, right? Next one, we're going to find cos inverse sine x equals pi by 6. So we're going to cos both sides. So you get sine x is equal to cos pi by 6. Cos of pi by 6 is cos of 30, which is √3/2 sine x. And x is equal to sine inverse √3/2. And sine inverse √3/2 is basically pi by 3, because sine of 60 is pi by 3, or 60 degrees. Now let's solve mixed problems. Now find the values of theta if cos x equals half. So if you're finding cos x equals half, x is equal to 60 degrees, all right? We will convert to radians now. So remember, to solve for x, we can say x is equal to cos inverse half. Now remember, this is a trigonometric equation, so we want to check where is cos positive. Cos is positive in the first quadrant and the fourth quadrant. So right, so it's positive here and there. First quadrant is theta angle, so 60 degrees plus 360 degrees k in degrees. If you convert to radians, it's going to be pi by 3 plus 2 pi k, general solution. So k is an integer value. O, remember, it's also positive in the fourth quadrant, right? So it's going to be negative 60 plus 360k, right? Or you can say 300 degrees plus 360k. Yeah, negative 60 plus 360k. If the value of k is 1, then you will get 300 degrees. Right, so that's your answer. You can convert this into radians as well. So these are your two answers. Look at the next one. Next problem is 3 cos squared x. You can make cos x equal to y. So you got 3 cos squared x minus, bring everything over because it's a quadratic. 4 cos x is equal to 0. We can take out cos x as a common factor, and we're left with 3 cos x minus 4 is equal to 0. So either cos x is equal to 0, or either cos x or 3 cos x minus 4 is equal to 0. So solve this, and you get cos x is equal to 4/3. But we know that the range for cos x is only between minus 1 and 1. Right? That's my cos graph, is 1 and minus 1. So there's no values of x that can make cos x equal to 4 over 3. So this is a reject, not applicable. You can try it out on the calculator and say shift cos 4 over 3 and see what we get, math error. So it does not work. But cos of x equals 0. Cos of what is 0? So we can see cos of pi by 2 and 3 pi by 2 is always 0. So pi by 2 plus every pi k. So we can just get a general solution, say x is equal to pi by 2 plus every pi k. I figured this out from the graph, okay? And k is an element of integers. You can see cos x is 0 every time when it is pi by 2 and adding a pi, right? So pi by 2 plus pi is 3 pi by 2. So this is my general solution for this answer here. If you convert it to degrees, it's going to be x is equal to 90 degrees plus 180 degrees k, where k is integer values. Next one, we want to simplify cosec over cos. What is cosec? Cosec is 1 over sine. Cosec is 1 over sine times 1 over cos, and 1 minus sine squared is cos squared x, because that is what is this? This is an identity. Sine squared plus cos squared is equal to 1. Sine squared x plus cos squared x is equal to 1. So what is 1 minus sine squared? 1 minus sine squared is cos squared x. So we know what cos squared is. 1 minus sine squared. There's it here. So we can see there's 1 cos x and 1 cos x cancels out, and we got cos x over sine x. And what is cos over sine? That is cot x. Now moving on to question 4, we want to simplify sine 345. So sine of 345 will be sine 360. We want to simplify this, okay? So sine 360 minus 15 degrees, okay? Which is equals to sine 360 minus 15 degrees is negative sine 15, because we are using reduction angle. It's 360 and 360, 180, 90, and 270. And then we want to simplify sine 255. Sine 255 is sine of 270 minus 15. Now, because we are using 270 minus 15, this is in the third quadrant. Negative in the third quadrant, and it changes to cos. So it becomes cos 15. So if you're multiplying the product of these two, so the answer is now equals to sine 15 times cos 15. Now look at this trick here. If I can take this and multiply by 2 over 2, I will get half because of the 2 is out. And if I group all this up, if I group up all this, I will get half sine 2 times 15, because it's a double angle. Why? Because remember, sine double angle is equal to 2 sine angle cos x, right? So 2 times 15 is 30. So half. What is sine of 30? Half. So my final answer is quarter. Moving on to the next question. 348. Cos 348 is the same thing as saying writing negative cos 12. Positive cos 12, because that's in the fourth quadrant. Tan 12 is sine 12 over cos 12. So I can clearly see cos and cos cancel out by sine squared 80 plus sine squared 10, right? So sine squared 80, I'm going to leave it just like that, sine squared 80 plus sine squared 10 is the same thing as saying cos squared t because of co-ratio. Right. The reason being is because if you're looking at the 30, 60, 90 triangle, remember, if this is 30 and 30, 60, sine of 30 is half, and that's root 3. If I ask you what is sine of 30, sine of 30 is the same thing as saying cos of 60. Now, how come? Because cos 60 is adjacent to the hypotenuse. So remember, if 30 plus 60 must give you 90. If the result is equal to 90, the sine and cos becomes co-ratio. If I ask you what is sine 2, if I ask what is sine of 20, then sine of 20 is the same thing as saying cos of 70. So very important co-ratio result. Now, going back here, because sine squared 80 plus changing the sine into cos, that is cos squared 80. I change the sine squared 10 to cos squared 80 because the sum of the angles needs to be 90. You can also change the sine squared 80 to cos squared 10, and then you got cos squared plus sine squared 10. Sine squared 321. 321 is sine squared 321, fourth quadrant, and either way, because it's squared, we don't need to worry about negatives because it is squaring. So sine squared 360 minus 321, I'm getting 39. Okay, so now next step, sine squared plus cos squared, sine 12 on top, divided by 1 minus 2 sine squared 39. And I know sine squared 39, 1 minus 2 sine squared 39, this is a cos double angle. So sine 12 divided by cos 2 times 39 degrees. And sine 12 can change to cos 78, okay? Because of this result here. Sine 12 and cos 78 is the same. And if I change the bottom, 2 times 39 is also cos 78. And what's the answer? Because the top and the bottom cancels out. And if you type this entire thing into, you should also get 1. The problem you might have is how to type this into the calculator. So let me just show you how to type a sine squared into the calculator. Actually, let's type the entire thing. So I'm going to do it quickly. Cos 348 times tan 12 over sine squared. So you need to put a bracket with sine squared 12 because you can't really put the squared there. Squared plus open bracket cos 10 close bracket close squared minus 2 open bracket sine 321 close bracket squared. Okay, I might have made a mistake somewhere, so let's go down. Squared there plus cos of 10. I think I made a mistake here. I know. Okay, going back here, it's not sine 12. Sine of 8, sine squared 80. Why did I put 12? Is 80. Yeah, so sine squared, calculator is in degree mode, shift mode, degrees. Again, cos 348, tan 12, divided by sine squared 80 plus sine squared 10. It's sine squared 10. Yeah, you should get the answer now, which is 1. So perfect. Moving on to the next question. Solve for theta if sine 25 is equal to cos theta. So we are going to use co-ratios, right? So we're going to say sine 25 is equal to, where is sine positive? So cos diagram, sine is positive in the first and second quadrant, so that's 90. Now, we are solving for theta, sine 25. Should check where is cos positive. So cos theta is equal to sine 25. Now check where is cos positive, because sine of 25 is positive. How we know sine 25 is positive? Because the sine graph starts like this, and that's pi by 2, which is 90 degrees, and 25 is somewhere around there. So that is a positive angle. So where is cos positive? First quadrant and fourth quadrant. But remember, we need to use 270 and 90 to reduce this. So we're going to say cos theta equals sine, not sine, cos of 90 minus 25. Okay, so now we're going to drop the cos on both sides because we're looking at quadrant 1 solution. So theta is now equal to 90 minus 25 is 65 degrees plus 360k, where k is integer values. Or cos is also positive in the fourth quadrant. Quadrant 4 solution will give me, so this is your general solution for this. Cos theta is equal to cos of 270 plus theta, 270 plus 25, right? 270 plus 25, which is cos of, remember sine of 25 is, remember sine of 25, sine 25. What's the answer? 0.4226. And what is cos of 270 plus 25? Is it the same result? Yes, it's the same result. So because we are using co-ratios, cos and cos cancel out. So theta is now equal to 25 plus 270 plus 25 plus 360 degrees k. And k is an element of integers. So these are your two general solutions for this problem here. So you must know how to solve trig equations. So this is general solution. This is general solution, general answer. If they only wanted an answer between on the cusp, we gave you a restriction like theta is an element from 0 to 360, then you don't need to add k360 here. So now you'll have specific solution, which is theta is now equals to two values for this equation. You say theta is now equal to 65 or 295 degrees. Okay, it as a set. Moving on to the next question. Find the value of cot squared minus cosec squared. Find the value of cot squared minus cosec squared. I think this is an identity, should be 1, but let's just double check. Let me expand cot. That is cosine squared x over sine squared x minus cosec squared is 1 over sine squared x, right? Same LCD. So you got cos squared x minus 1 over sine squared x. So this is, remember what is cos squared is, remember sine squared x plus cos squared x is equal to 1. So what is cos squared minus 1? If I bring the 1 over, that will become negative sine squared. Negative sine squared x over sine squared x, which is equals to negative 1. But if you already know the identity, it's supposed to be cosec squared minus cot squared is equal to 1. Next one, what is cosec x over sec x? So cosec x is 1 over sine x, and we're dividing it by sec x, which is 1 over cos x. So you keep change flip, so you're getting 1 over sine x dot cos x over 1. So cos over sine, which is cot x. Moving on to the next problem. Find the value of cos 2 beta if sine beta plus cos beta is equal to 1.25. So what we're going to do is we're going to use a squaring technique because we want cos double angle and we have a single angle. So we're going to square both sides, right? If you're squaring both sides, we get sine squared beta plus middle term is very important, 2 sine beta cos beta plus cos beta is cos squared beta is equal to 1.25 is 1.25 squared is 5 over 4 squared. Sine squared plus cos squared is 1 plus sine 2 beta is equal to 25 over 16. We will take 25 over 16 and we will minus 1. Now don't minus 1, minus 16 over 16. So I will get 9 over 16. I got sine 2 beta is 9 over 16. 9 is the opposite. This is the triangle for 2 beta. The opposite is 9 and that is 16. So the adjacent will be the square root of 16 squared minus 9 squared. 256 minus 81 plus 5. 5 minus 8, I can't do that. So that's 15 minus 8, 7, 175. And 175 is equal to 25 times 25 times 7, I think. 25 times 8 is 200. So 25 times 7. So this is equal to square root 25 times 7, which is 5 root 7. Right. So I've got the adjacent, which is 5 root 7. So what is cos 2 beta then? Cos 2 beta is 5 root 7 over 16. Okay, so I've got an answer for cos 2 beta. Hope you guys understood that. Moving on to the next one. What is sine theta over sine theta? What is sine theta cos theta? So we can clearly see that sine and sine cancel out. We're just taking cos theta dividing by cot theta. So cos theta divided by cot theta is cos theta over sine theta. So cos theta times, keep change flip, sine theta over cos theta, which is cos and cos cancels out. We just get sine theta as the answer because those cancel out. And, right, so moving on to the next question. Question 11. We know pi by 6 is 30 degrees. So obviously pi by 12 is 15 degrees because we're halving both sides. So what is 7 times 15? 7 times 15 is cos 105. It's better to work in degrees. So that's going to be cos of 60 plus 45. Cos 60, cos 45 using sum of angles formula minus sine 60, sine 45. Cos of 60 is half. That's root 2 over 2. Minus sine 60 is root 3 over 2 and root 2 over 2. So we're getting root 2 minus root 6, root 2 over 4 minus root 6 over 4. So root 2 minus root 6 all over 4. Hope you guys understood that.